Hello class and welcome to my culminating presentation. This is what I built and it is what I will be presenting to you guys today. I will start off by bringing you guys over to a little town that I named Networkville. As you can see, Networkville consists of 4 little houses with lights on the bottom blocks. None of the lights are turned on, however. The lights are all connected through wires to one switch in what I like to call the mainframe. You will see why it is called the mainframe shortly. As I walk into the mainframe, there is the switch. Flick on the switch, and the redstone turns on. The redstone in this represents the wiring. When a redstone is on, it represents current flowing through the wires. The current flows through the wires and reaches the lights in every house, turning them on. Networkville represents the networking units that we covered in class because each house represents an IP address, and the mainframe represents, well, what would also serve the purpose of a mainframe in real life. When I go to the mainframe and flick on the switch, I am implicably giving the houses the internet connection if they were actual IP addresses. So each house is an IP address. When I turn on the switch, give them power, I'm implying that I am allowing them to access the internet from the mainframe. Now, as you can see, this is the wiring. This right here is called a repeater, which essentially elongates the current because, as we all know, current can only travel so far and it eventually weakens. As you can see, it is darker over here than it is over here. That is because it is stronger over here than it is over there. And the repeater essentially allows the current to restart as if it was the source itself. So that's Networkville. And moving on, I will bring you over to what I called the circuit house. The circuit house, if you can't already tell, represents the electronics unit that we covered in class because we built circuits during that unit. In this unit, we had an assignment where we presented a few circuits, and I essentially copied that idea and did it myself, but in Minecraft. The first circuit we have here is a switch, which is the source of energy, redstone, which is the wire, and the load, which is the lamp. The switch is currently on. If I flick it off, no power is flowing from the source through the wire to the load, therefore the lamp does not turn on. Very simple circuit. Second circuit, source, wiring, repeater, because otherwise the wire would not be long enough, or the redstone would not be long enough to carry the current all the way through, and again a load, which is the lamp. Third circuit, I introduce something called a comparator. The comparator can be connected through the sides and the back. When the input through the back of the comparator is greater than the input from the sides, the output is equal to the rear input. As you can see, there's no flow coming from the sides, so the output is equal to the input. Now, the comparator has 2 modes: comparative mode and subtractive mode. Subtractive mode means that it will subtract the current from the side power from the rear current. As you can see, at the moment it is in comparative mode, which means it will just compare the currents, and when it is in comparative mode, the output current equals the input current. However, when I switch it to subtractive mode, the output current gets a lot weaker. The reason for that is because it is taking this current and taking away this current from it, taking away the power of this current from the power of this current. And this is essentially the subtraction of that. The fourth circuit simply introduces a piston. As you can see, when power flows through it, when a current flows through it, simply shoots up, shoots in any direction that the piston is pointing in, off, on. Next we have what we call a observer. The observer has a detecting side and a emitting side. The detecting side detects any motion, and when it detects motion, it will emit a short pulse of energy. As you can see, the pulse of energy is only for the instant that it detects the movement. Short pulse, for the instant that the action happens. It does not stay, even if the redstone is on the whole time. Now we introduce what I like to call a beating circuit. Why? Because it beats like a heartbeat. As you can see, when you get a comparator and you have it in subtractive mode, and you have one wire coming out through the front and one wire coming out through the side, and you link them, the current starts pulsing on and off. So it hits the load in an on and off pattern at certain intervals, making the piston, in this case, shoot out over and over again. Lastly, we have a very complex circuit. Well, not very complex, but more complex in the sense that it combines everything that I showed previously. You flick on the switch, we have a comparator creating an on and off circuit, splits into two, reaches two observers, triggers them, causes them to send pulses, creating the same on and off circuit, reaching another observer, which detects the on and off circuit through this side, emits the current through this side in an on and off pattern into the piston, which allows the piston to act over and over again at certain intervals, which hits another observer in the detecting side, which causes the observer to emit another on and off current that is long enough for a repeater to be required, which extends the current over to a lamp. And because it is an on and off circuit, the lamp will turn on and off at intervals. That is it for the electronics unit. Moving along, I want to cover the section that has to do with jobs, essentially. Over here is a high school I built. As you can see, Alejandro Secondary School. And over here we have a McDonald's and what is supposed to be the dollar store. Now the reason why I put a McDonald's and the dollar store here is because they are jobs that require nothing to get. And after high school, even after completing high school, you don't really have what you need to get a proper job. So the most you can get would be something like this. That's why I got it. That's why I built it, rather. Moving on, I built a university over here. Alejandro University. And attached to the university is the Honda headquarters. And here is where supposedly all the car engineers work, and all those people work in designing cars and stuff like that. And I put that here because it shows that with a good education, you can typically get a good job, such as being a car engineer at the Honda headquarters. It looks nicer and you'll be making more money. Lastly, I want to introduce you guys to a little invention of mine. Nothing too complicated, because I can't really bring to life the complex invention that we came up with at the beginning of the semester. Simply a little light show. I used rails that react when a cart moves above them, and they emit a pulse as long as the cart is above them. As you can see, the cart is above this tile. It is sending a current through the redstone or the wiring into the lamp and turning it on. I will now demonstrate how it looks when you are in the cart and driving around. As you move The one that you pass turns off. The one that you move into turns on for as long as you are on that tile. And that concludes my presentation. Thank you all for listening.